Our first question comes from page 397, numbers 87 and 103. Number 87 asks to write Lewis structures for the following. Show all resonance structures where applicable. Part A is NO2-, NO3-, and N2O4. Part B is OCN-, SCN-, and N3-. Number 103 asks to predict the molecular structure and bond angles for each molecule or ion in exercises 81 and 87. Number 87, Part A, asks to draw the Lewis structures with resonance for NO2-. So N starts in the middle, and O is on either side. One O will be double bonded, and the other O will be single bonded to the end. The N. This has the 3 of the 5 valence electrons on N, so you fill in the other 2. Now O each have 6 valence electrons, so there's 2 on this one. So you add the other 4 to make it 8 to fill the octet rule. And the O on the other one is going to have 6 as well. So 1, 2, 3, 4, 5, 6. But that's only 7. It does not fulfill the octet rule. So you have to add the minus from the outside world. And then since it is an ion, do 1 minus. And the resonance structure for NO2- will be the same, except the double bond is on the other O instead of this one. NO3 is going to have 3 resonance structures, moving the double bond from each O. The double bonded O is going to have 4 lone electrons because that fulfills its octet rule. But each single bonded one will have to gain an electron from somewhere else because that does not fill the octet rule. So this O will get its electron from N because N has 1, 2, 3, 4 right now, and it needs 5. So this 5th one that would be up here is going to come to this O. And this O is going to get the electron that comes from the minus in NO3-. And the same will happen on all 3. These are the completed resonance structures for NO3-. N2O4 is going to have 4 resonance structures, moving the double bonds on the oxygens from each one. The double bonded oxygens are going to have 2 lone pairs on each one to fulfill their octet rule, but the singular ones will be 1 short. So they're going to have to take 1 from each of the nitrogens because the nitrogens will have 1 lone here to give. So we'll give it to them, fulfilling their octet rule. Here's the completed resonance structures for N2O4. In Part B, the first one is OCN-. OCN- is going to have 3 resonance structures, the first having double bonds on each the N and the O. For the double bond on the O, since it has 6 valence electrons, you will add the 4, and this will fulfill its octet rule. But for the N, it has 5 valence electrons, which leaves it 1 short of the octet rule, so the minus will add it. The second structure has N triple bonded to C and O single bonded. So the triple bond on N, that is 3 of the 5 valence electrons, so you add 2, and that fulfills the octet rule. But on the O, it has 6 valence electrons, which leaves it 1 short of the octet rule, which is where the minus comes in and completes the structure. The last resonance structure for OCN- has O triple bonded to C and N single bonded. O has 6 valence electrons, so it has 3 here, so we'll have 2 more here to make 5. But that already fulfills the octet rule, so the 6th one's going to come over here to N, and N usually has 5 valence electrons, so 1, 2, 3, 4, 5. And it's still 1 short, which is where the minus comes in. These are the complete resonance structures for OCN-. SCN- is the next resonance structures, and the first one is going to have a double bond on each S and N. And to complete S's, you will just add 2 lone pairs to fulfill the octet rule. But on nitrogens, it has 1, 2, 3, 4, 5 valence electrons, so the minus will come in to fulfill the octet rule on that structure. The next resonance structure will have S triple bonded to C and N singular bonded to C. Now, you just have to add these 2 valence electrons onto S to fulfill its octet rule, but it will have an extra since it has 6 electrons. So that extra will come over to N, and N has 1, 2, 3, 4, 5 valence electrons, and that still is not enough, so the minus will come in to finish that structure. The last resonance structure has S single bonded and N triple bonded. So S has 1, 2, 3, 4, 5, 6 valence electrons. It needs 1 more to fulfill the octet rule, so that will come from the minus. And N has 1, 2, 3, 4, 5 valence electrons, and that fulfills its octet rule. These are the completed resonance structures for SCN-. Similar to the last 2, N3- is going to have 3 resonance structures, and the first one will have 2 double bonds. On the double bonds, N has 1, 2, 3, 4, 5 valence electrons. This 5th one will come over here to this N, and this has 1, 2, 3, 4, 5 valence electrons. That 5th one that came from that N fulfills its octet rule. On this N, it's going to have 1, 2, 3, 4, 5 valence electrons, and the last one will come in from the minus to fulfill the octet rule. The next resonance structure is going to have 1 N single bonded and the other one triple bonded. The N that is single bonded will have 1, 2, 3, 4, 5 valence electrons. But even though it has an even amount, it does not fulfill the octet rule. So it's going to take the valence electron that would be up here, and it's also going to take the valence electron from the minus on the ion. And the one that is triple bonded will just have its 2 valence electrons to have 1, 2, 3, 4, 5. The same procedure will be on the last resonance structure, except the triple bond will be on this N instead of that one. These are the completed resonance structures for N3-. Number 103 asks to identify the shapes and bond angles for questions 81 and 87. These are the Lewis structures for number 81. So CCl4 is going to be a tetrahedral because it has 4 off of the central atom and no lone pairs. And tetrahedral is 109 degrees. NCl3 is going to be pyramidal because it has 3 off of its central atom and 1 lone pair. And pyramidal is also 109 degrees. SeCl2 is going to be bent because it has 2 off of its central atom with 2 lone pairs. And this is also 109 degrees. ICl is going to be linear. But since it is only 2 molecules, it has no bond angle because diatomic molecules have no bond angle. The same procedure goes for number 87, and NO2 is going to be bent and 120 degrees because of the 1 lone pair off of the N on the resonance structures. NO3 will be trigonal planar and 120 degrees because it has 3 off of the central atom and no lone pairs. N2O4 will also be trigonal planar and 120 degrees on both of the N atoms. For part B, all 3 of these structures are going to be linear and 180 degrees because they all have 2 off the central atom and no lone pairs.